Hello, ladies and gentlemen. First of all, I want to thank to the organizer for the invitation of the Apollonia Congress, and in the next 10 minutes I will present briefly the synthesis, characterization and potential applications of sand polyelectrolyte composites obtained in laboratory functional polymers from Petroponi Institute of Macromolecular Chemistry. The motivation of study is to create an environmental friendly and cheap sorbent material which can be used in water purification. This sorbent must interact with heavy metal ions at low concentration and other types of pollutants such as drugs and dyes. Among different natural materials used in water filtration, we used sand because it is a natural, abundant, mechanical resistant and chemical stable support. The objectives of this study is to create a pH stable composite based on sand and polyelectrolytes with high sorption affinity towards different pollutants such as heavy metal ions. The natural sand was sieved with a sieving system and 7 fractions were collected. The name of each fraction was identified with the sieve size. 70 means 70 microns, 100 means 100 microns, and so on. Each fraction was characterized by morphologist 3 GSA, which is an automatic optical microscope able to measure each sand particle. From these measurements, we can calculate the average diameter for each sand fraction. With this value of diameter, we can estimate the external surface based on approximation that each sand particle is a sphere. The convexity and solidity measurements, which shows the roundness of particle, shows that we can make this approximation. The organic part of the composites consists in 2 polyelectrolytes and a crosslinker, which is able to stabilize the organic architecture on sand particle. The polyelectrolytes are polyethylene imine and polyacrylic acid with close molecular molar mass. The sand mass distribution show that fraction F200 and F100 are the most abundant fractions in polydisperse natural sand. The polyelectrolyte sorption experiments shows a very low salt amount of polycation due to the low external surface of the sand. The maximum salt amount corresponds to the lower fraction and decrease with the sand particle size. Using only pH sorption, it's hard to deposit on sand particles high amounts of polyelectrolytes. Therefore, we tried a new method for deposition, which is a precipitation of interpolyelectrolyte complex followed by chemical cross-linking and pH extraction, obtaining in the final a composite, a stable composite, sand polyethylene imine. The same images show the film formation on solid surface, and XPS measurements confirm this fact. Based on XPS survey spectra, we can estimate the amount of organic part deposited on each fraction. Using TG and nitrogen to silicon ratio, it's clearly that lower sand fractions contain higher amounts of cross-linked polyelectrolyte layers. Also, unmodified sample contains organics. Therefore, the deposited amount was calculated as difference between modified and unmodified samples. The maximum sorption capacity toward heavy metal ions was evaluated by copper sorption on each modified sand fraction. The sorption capacity decreased with the increasing of the sand size. A major advantage of this type of composite is the reusability in multiple sorption-desorption cycles. Column studies of heavy metal ion sorption on F100 sand page show 2 aspects. This type of sorbent can clean water by sorption of all 6 heavy metal ions, non-competitive regime, and 2, the sorbent can extract only copper ions by selective desorption of all 5 ions previously sorbed in column. At the end, the exhausted column being loaded only by copper ions. Using ABTA solution, we can see that the columns are fully loaded, 12 milligram per column with copper. Only small traces of other metal ions being recorded at the end. After extraction and washing, we can reuse the column. Using PEI, a polycation, a polyanion, and a crosslinker, it was successfully deposited on organic layer onto sand particles. This composite fulfills the requirements to be considered a solvent for water treatment and chromatographic support. I want to thank for the financial support to the project PED 521 Polysound, and to you for the attention.